Today we're going to see about vectors in Matlab. So the Matlab provides us with a series of functions and features that allows us to work with vectors, some of which we'll be seeing in today's lecture. So we have the column vector, which allows us to create and index elements. We have the linspace that allows us to work with linear space vectors. We have concatenation, which can be used for merging of vectors. Then we have initialization vectors with rand zeros and ones. Then if you want to resize or reshape the vectors, you have a reshape option. Then you can use certain arithmetic operations on vectors and element wise operations on vector. So let's get started, and first we'll see how to do with row and column vectors. So here what I'm doing is I'm writing a column vector and then I'm doing a row vector. So for column vector, I have put the elements within the bracket separated by a space, and for my row vector I am doing the same thing with a semicolon separator. Now what is the difference between, how do you know which is a column vector and which is a row vector? So whenever I say column, the horizontal should come to mind, because a column vector, if you see, it is in a horizontal direction, and if you see a row vector, it's going to be in a vertical direction. Now if I take the size of the column vector, I'll just display the size of column vector. I won't put the semicolon, so I see the output right away. Then I see the size of my row vector. Okay, so let's run this again, and then I'm seeing for the size of my column vector, I'm seeing 1,5. So which means the column element is 5, because which is the column and which is the first one is the row. So I have 1 row, 5 column. So this means the size of the column vector says 1 row, 5 column. And the size of the row vector says 5 rows, 1 column. It should be 5 rows, 1 column. So this much I know, and I can tell that the element which is non-unity, so which is not 1, that tells me which vector it is. So when the row is not 1, then we call it as a row vector, and when the column element is not 1, then we call it as a column vector. Or the horizontal and vertical direction should also help you identify a row and a column vector. Okay, so that is for the row. And how do we project it? With the space and a semicolon in Matlab. Next thing I would like to talk about is the transpose of a vector will give the opposite type. So what does it mean is, if I take a column vector and I do its transpose, I'm going to get the row vector, and vice versa. If I take a row vector and I do its transpose, I'm going to get a column vector. So this is what I am displaying here. Let's just run this and see. So you can see the row vector from transpose, I'm getting it 1, 2, 3, 4, 5, and the column vector from transpose, I'm getting it as 1, 2, 3, 4, 5. So this is pretty much how you get a column vector and a row vector. Okay, so I've taken the column vector, I took the transpose, I get the row vector. I like row vector, I take its transpose, I get the column vector. Okay, now I'm going to show you how to generate vectors using linspace. So we can generate vectors using spaces and semicolon, just we discussed, but it becomes more practical to use some Matlab functions to generate a large size vector. For a small size vector, it's manageable by typing, but when you have a need for generating a larger size vector, then it's better to use linspace. So here we are going to see how to create vectors using linspace. So the linspace is given in this manner. The column vector using linspace I'm generating is 1,5. So what the linspace tells Matlab? So the linspace function tells Matlab, or what is this 1,5,5 tells the linspace function? It tells the linspace function to generate 5 values between 1 and 5. Between 1 and 5 that are linearly spaced. So we'll come to that linear spacing in a bit. So I'm going to generate 5 values between 1 and 5 that are linearly spaced, and that is exactly what I'm getting. So what is this linear spacing? So let me just increase this to 10 values and see what I get. I get something like this. Now I'm going to do something here. I'm going to take the difference of these values. Okay, I'm going to take difference of this lin vec space. Then let me see what I'm getting. I'm going to remove the semicolon so that I can see the output. And if I see the difference, if you see the difference between the consecutive values are the same. Okay, so it's 0.44, 0.44. This is what the linear spacing does. So this is, I would say, linear spacing means the difference here, at least in this case, difference between consecutive values are the same. Next, we are going to see vector concatenation. So by vector concatenation, we mean that we are able to connect vectors, we are able to join vectors, we are able to merge vectors, and that is a very useful features when we work with computational algorithms in Matlab. So I'm going to have two vectors here. I'm going to call this as a first half vector, and I'm going to call this as a second half vector. Then I have something called as dimension joining. So I'm calling dimension joining because I want to define in which dimension I want to join. I have two ways to do it. So I can take one vector and put it one beside the other. So that will be like the horizontal joining. Then I take one vector, then I will put it one beneath the other. So that will be like vertical joining. So I can do this in two ways. So let's just I'll just disable this output so that I can show you what is first half. So the first half vector is 1, 2, 3. Then the second half is 4, 5, 6. And you can see that I'm concatenating. So I'm doing the concatenation using a function called as cat function in Matlab. So I have to define three variables here. The first I have to define the dim join. Then I have to define the first half vector and the second half vector. So when I do this, you can see that it's taking one vector and putting the next vector besides the other. So this is like, I would say, it's a horizontal concatenation. So you get one big horizontal line of vectors. And then here, if I give dim join is equal to 1, then you can see that the vectors are put one beneath the other. So 1, 2, 3 is my first half vector, and 4, 5, 6 is my second half vector. So it's going one beneath the other, and it means it's vertically concatenated. It's just putting it in the vertical manner. So you have these two concatenation with the help of your cat function. But that is not, you don't need, for vector concatenation, you don't always have to use this cat function. Okay, it allows us, there's a much straightforward and much simpler way of doing concatenation, that is using just plain brackets. So what we are going to do is, here we are going to again generate our first half vector and the second half vector. So to concat horizontally, you just have to put the first half vector within the close bracket and have a comma, okay, and you separate it with a comma, and then you put the second half vector. So let us see, and then for concatenate vertically, just separate with a semicolon. Okay, so this will give you the horizontal concatenation. So 1, 2, 3 and 4, 5, 6. So whenever you horizontally concatenate, you are increasing the number of columns, right? So column is represented in a horizontal, and vertical means row. So it gets a little bit of time to get used to that row, column, and vertical and horizontal analogies in Matlab. But I think you will catch up as we go with this, like a lot of lectures. So this is the vertical concatenation. So you have 1, 2, 3 and 4, 5, 6. Okay, then let's come to the next thing is, for this concatenation to happen, there is a condition in Matlab, that is the arrays or the vectors must be of the same dimension. Okay, so the dimension should match, otherwise the Matlab doesn't know how to concatenate or where it is missing. So for example, I am now before my first half vector was 1, 2, 3. I am reducing the size of the first half vector to 1, 2, and then I'm keeping the second half vector 4, 5, 6. Okay, and now I'm trying to concatenate it. So I'm going to concatenate this one. Okay, so I'm going to concatenate it. Maybe I think we won't keep this from now onwards. We can because it is used for displaying output, but I can also use this semicolon. If I remove this semicolon also, I'll see the output. So I'll just because this is something I want to show an error message, not an output actually. So you can see that you get an error because the first vector is 1 cross 2 and the second vector is 4 cross 6. Now let's see what happens if I remove the semicolon. So when I remove the semicolon and I leave it with a space, I'm going to do the horizontal concatenation. So let us see, will that work? That will work. See this? So the Matlab has done the horizontal concatenation because here it knows that you have to be, it has to put 4, 5, 6 after 1, 2. So always the horizontal concatenation will work and the vertical concatenation on the other hand will fail. You do it in this manner, the vertical concatenation will fail. So this is one thing you have to note. You say horizontal concatenation will work for different dimensions. Vertical, however, fails if dimensions don't match. Alright. Okay, so it will work if it is a horizontal concatenation. Okay, so that is pretty much what I wanted to show. If I put a semicolon here, you get an error. So I'll just put okay, full vec. This will don't work. Okay, then that is what the concatenation does. Next, we'll quickly go into the computation with vectors. Okay, so we're going to do some computation on the vectors. So let me just disable this line for now, otherwise I cannot go further into this. I take two vectors, 1, 2, 3, 4, 5, 6, then I can do the sum of the vectors. The sum of the vectors will pretty much do this 1, 2, 3 here. Then I take the difference of the vector, so it takes the difference between the elements. So I'm taking the first vector, and if I take the sum, it's going to do 1, 2, and 3. So the sum of the vector is going to do 1 plus 2 plus 3. Then for my second vector, if I do the difference, it's going to take the difference between these elements, 5 minus 4, 6 minus 5. So when I run this element, when I run this, you can see sum of all elements in vector 1 is 6. The difference between the element in vector is 1, 1. Now if I change this to 4, 5, 8, then do the running, the difference changes 1, so this is pretty much what we do with the difference. And you have other functions, mean, vec, this one, you can find the minimum, you can find the max, or you can find the median I have put. You can do this also, minimum, maximum, cum, sum, median. So these kind of statistical operators are also can be used in the vectors on easily with vectors with Matlab functions. The next important thing when we talk about vectors is the dot product and the cross product. So you know that vector algebra always works with dot product and cross product, and in Matlab you have direct functions for dot product and cross. So you just you know formula how it works. So you just have to do the dot product of two vectors, and then you do the dot cross product of two vectors. So we have the dot and cross functions. So it's not much explaining is needed for this. Here also maybe the dimension will be always, you know, when you change the dimension, one of the error will be A and B must be of same size. So that is something you have to keep in check with all the computations. You know, whenever you do a computation between two vectors, at most of the times, I would say like about 80 to 90% of the times, the vectors have to be having the same dimensions for the operations to take place. If not, it just throws an error, the dimension mismatch, or A and B must be of the same size. So you just have to adjust your vectors such a way that it can be computed with the same size. Okay, so now we have the dot and cross product features. Next is another useful feature, that is element-wise operator in vectors. So now what I'm going to show you is something that will work in the elements of the vectors. So that is called as an element-wise operation in vectors. So basically what it does is I'm taking the same vectors 1, 2, 3, 4, 5, 6 for all my explaining, so that it's easier for you to follow what's going on with the numbers. I'm going to have this operator. You see this dot, asterisk, dot, slash, and dot to the power. So this is my element-wise multiplication, division, and power operator. And basically what I'm doing with this, I take my first vector, then I multiply it with the second vector. But I cannot normally multiply because of the dimension problem, right? The matrix multiplication is not possible because of the, if I just do the multiplication, then I have to make sure that it is having the matrix compatibility. But in this element-wise operation, what I'm telling the functions to do is take one element, take each element and multiply it with one another. So let us just run it here. So you see here, I'll just remove the semicolon so that I will get the output here. So the vector 1 is 1, 2, 3, and the vector 2 is 4, 5, 6. The element-wise operator is pretty much what we see here is we are going to see the product of two vectors, 1 into 4, 2 into 5, 3 into 6. So here I can write it in this manner, 1 cross 2. Right? I'm doing 1 cross 4, sorry, 1 cross 4, 2 cross 5 and 3 cross 6. And this is going to come out as 4, 10 and 18. You see the output is 4, 10 and 18 in this one. Next is I'm going to do the division. I'm going to say take the same thing and I'm going to do but I'm going to do vec 2 by vec 1, right? So I'm going to do vec 2 by vec 1. So I'll just put vec 1 by vec 2. So I'm just going to replace this with division. 1 divided by 2, 4 divided by 6, and I get my answer as, now if I run it, I'll be getting it as 0.25. 1 by 1/4 is 0.25, 2/5 is 0.4, 3/6 is 0.5. And for the power, the same thing. I'm going to take the power of this 1 to the power of 4, 2 to the power of 5, and 3 to the power of 6, and that's going to come some pretty big values. So 1 to the power of 4 is 1, I don't know what it is, yeah, 2 to the power of 5 also 32, and 3 to the power of 6, no idea, but it is 729. And that is pretty much what your element wise operation. It's applicable for multiplication, division and power, and you know that this is where the problem comes when compatibility, with the size compatibility. So Matlab allows us to use this element wise operator to take care of this problem. Next, for addition and subtraction, you don't have to use the element wise. You can just put your plus and minus and you just get the sum. So it just takes each element and it does the sum. So if I take this element, you will see it's just going to do 1 plus 4, 2 plus 5 and 3 plus 6, and you get this 5, 7 and 9, and then the same thing, you will get it as a subtract. You do 1 minus 5, 2 minus 5 and 3 minus 6, and then you get the subtraction. Minus 3 minus 3 minus 3, 5, 7 and 9. Okay, so that is for your vector arithmetic operation and element wise operation. Next, we have something we would like to point out is the vector indexing. So now, yeah, I've already told this before, so we'll not use disp here onwards. So we are going to use just skip semicolon. So if I just don't put this semicolon at the end of my what is that, end of a sentence, then that will automatically display the output on my screen. So I'm going to use that because I was using disp because that's very basic learning and teaching. And now as we are moving into little more intermediate features of vectors, we're going to see just without the disp, and hopefully you can it won't make much difference with the output displayed here. So I'm going to generate a vector. So I'm going to index a vector. So what I'm going to do is I'll just here also I'll put it as 1, 2, 3, 4, 5. So I'm generating a vector. So my vec 1 is displayed. So that is 1, 2, 3, 4, 5. And vec 2 is displayed as the transpose of vector 1. So I have a horizontal vector and I have a vertical vector here. And now I'm going to choose the third element from each of the vectors. So to choose the third element, I'm just going to give the index of that element. For vectors 1 and 2, it will work. Okay, I can just index it. It will work whether it is a row vector or a column vector. It don't matter. You can use row or column vector, can be indexed in the same way. Indexed in same manner. Okay. So that is pretty much what's happening here. And now if I want to choose a group of elements from the vector, so I want to choose the first 3 elements. So I'm just doing 1 colon 3. So 1 colon 3 tells me that choose from 1, 2, 3 elements. This is what I do. Then 2 is to n is like choose from 2 to the last element. So this tells us choose from 2 to the last element, 2 to the last element. Then I can see the output. I can see 1, 2, 3. In vector 2, I'm choosing the second element is 2 to last element, 2, 3, 4, 5. If I choose just 4 to n, then I'll get only 4 and 5. If I choose this, I get only 4 and 5. Got it. I have another useful feature, vec 3 element. I'm going to do is vec 2 of 1 is to 2 is to n. So I'm going to take every alternate element. So this means 1 is to 2 is to n mean pick 1 first element, then it goes third element, fifth element, so on. So basically what it does is 1 first element it will pick, then it goes for 1 plus 2, that is your third element, then it goes for 3 plus 2, that is your fifth element. So it goes first element, then 1 plus 2, third element, and fifth element. I'm not having a semicolon, so I'll be able to see the output. So the vec3 element is 1, 3, 5. So I'm skipping. So if I want an even element, I just put a 2, then it goes 2 and 4. I get my even element. So you can use this colon operator. So basically, vector indexing in Matlab is using colon operator. Right. So the colon operator becomes very handy for and that allows us to select elements, pick elements, and do some change to our vectors, because here the vector size is now just 2 cross 1. The original vector is 5 cross 1, so you can even resize your vectors in this way. Now we have certain functions that can be used for initialization of vectors. So basically what happens is you want to initialize a vector, but you don't know the values, because here we are using 1, 2, 3, 4, 5, that is consecutive values, and most of the case the initialization happens to have zeros or ones, or it can have some random values. Okay, so we can generate, because the distribution is not known, we go with the random distribution. So these are some of the functions that will help us generate. So vec ones of 1, 5 will generate all ones. The random will generate normally distributed random values of 1, 5. Zeros will generate 0 vector. This is a unity vector. This is a 0 vector. Right? We can even call this as a. We cannot call it a unit vector because maybe unity vector. We can call it as a unity vector. Unit vector has a different dimension in mathematics. This is a 0 vector, and this is a random vector. So we can generate these. Both of these are random vectors. So random vectors normalized, I can say. This is just a random vector. Okay. So now here I get a random integer values between 1 and 5. Okay. The range is between 1 and 5 and between 1 to 5. So this is the minimum value and the maximum value in the range. So this is already discussed here. Range is given by 1, 5. Okay, so it means it picks the values between 1 and 5, and size is given 1, 5. So this is my size of the vector. If I put a 5, 1, okay, what will I get? I get a random vector between 1 and 5. The size is 5, 1. If I put 1, 5, I get a vector with the size 1, 5. Okay. So these are all from the previous section till now we are coming to a little bit of intermediate. It's not the basic, but still you need to know this because in intermediate course we'll cover a bit more details on these. Then the last one for the vectors is the reshaping. So changing the size of the vector. So you have a vector. This is 1 to 9, and I can know the size of the vector. I just have to calculate the length of the vector. Now I know the length of the vector is 9 because if I do this, I know I'm going to get 9. So which means I can reshape the vector to have 9 elements. So I am going to reshape it into 3 cross 3 array. So this is no longer a vector, it becomes an array, and that's going to be our next topic also. So what I'm going to do is I can use the reshape function. I have reshaped the vec1 because the vec1 is having 1, 2, 3, 4, 5, 6, 7, 8, 9. When you reshape it into 3 cross 3, when you do the 2D reshaping, right, it has to have the same elements. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it has reshaped in this manner. Here also you can specify the dimension, so we won't go much into that. But only thing is, if you put it as 3 cross 4, then you see here you get an error because the number of elements don't match. So you're telling Matlab to reshape it into a 12. You have a matrix of 12. 3 cross 4 is 12 elements, but you're giving an input of only 9 elements. So this always has to match. So this product 3, 3. So 3, 3 array will give 9 elements. So this should match the length of the vector. So your vector length is 9. So I can have only 3 cross 3 reshape, or I can do a 9 cross 1. For that I can also take a transpose. This also will work. If I do a 9 cross 1, I get it in this manner. Or I can do, pretty much only these are the factors. 3, 3, 9, 1 for my 3, 9, 1, right? So these are the factors, so I can do the reshape. So reshaping is also a very useful feature, but this comes a little bit on the intermediate side, so we'll stop here for this lecture. Thank you guys. I'm uploading the GitHub link also in the description. Please download it, learn it, and any doubts please post it in the comments. Thank you.